This Zoom session is being brought to you by the Fractal Inverse Bullseye S Swirl. Okay, for today, we'll be doing section 7.3, hyperbolas, and 7.4, shifting conic sections. All right, we proceed. A hyperbola. It's this kind of wasp waist shape. I think of it as you put a lamp against the wall and light it. It makes a hyperbola shape shadow on the wall because the light is coming out the top and the bottom. Anyhow, it's also the set of points P, such that the distance from P to two fixed points F1 and F2, the foci, differ by a fixed amount. So here's F1, here's F2, and the distance PF1 minus PF2 is a constant. Absolute value is a constant. If you just drop the absolute value sign, you might get one branch of the hyperbola, and if you reverse them, you get the other branch. But absolute value, you get both branches of the hyperbola. These have two lines called the asymptotes. They approach and never quite reach the asymptotes, but they get ever closer. Here and here. All right, a classic. Okay, the formula for hyperbola. Here's the formula for hyperbola. X squared over a squared minus y squared over b squared equals 1. Now, its graph looks something like this. It has vertices plus or minus a by 0 here and here. Foci are plus or minus c by 0, as c is root of a squared plus b squared. And asymptotes y is plus or minus b over a x here and here. So what you do is, given this formula, it's x is in front, then you vertices are here on the x-axis, plus or minus a. Then you put plus or minus b here. You can draw this box here. And the diagonals of the box are the asymptotes. And these are the vertices. And it comes in from the asymptote through the vertex and back again. Asymptote, vertex, back again. Now, if it's y squared over a squared minus x squared over b squared, so that y is a variable in front, then it's well, much the same, though not exactly. Okay, because it's y over a, we put the a at 0, at vertices at plus or minus 0 by plus or minus a. We draw plus or minus b here, draw the box here, draw these lines here. These are the asymptotes y equals plus or minus a over b, x, and the vertices, the foci are here and here, 0 by plus or minus c, where c is again root a squared plus b squared. So, for example, find vertices, foci, asymptotes, and graph of y squared over 36 minus x squared over 4 equals 1. Well, first we write the 36 and the 4 as respectively 6 squared and 2 squared. The y is in front, so the vertices are on the y-axis. They're at 0 and plus or minus 6. We go up and down 6, we go back and forth 2. Draw this box, draw these diagonals. Those are the asymptotes. And the graph is like this and this. The vertex, the foci are at 0 by plus or minus c, where c is root 6 squared plus 2 squared, which is about root 40, 6.324. So about 6.324 here and here, root 40. And y is plus or minus 3x, the asymptotes. Same question for x squared over 4 squared minus y squared over 16 equals 1. Okay, right, the 4 is 2 squared, the 16 is 4 squared. Okay, x is in front, so the vertices are on the x-axis. Vertices are at plus or minus 2 by 0 here and here. Here's this 2 and 2. We could go up and down 4, draw this box, draw these diagonals. Those are the asymptotes. The graph comes in from here, goes through here, goes out here. From here through here, goes out there. So those are the asymptotes of plus or minus 2x. The foci are on the y-axis, where c is root 4 plus 16. That's root 20, about 4.472. So the foci are at plus or minus root 20. Actually, oops, plus or minus 0 by root 20. My mistake. No. Oh dear. They're here and here. Ignore these. Plus or minus root 20 here and here. Now here we go the other way around. We start with the foci and the vertices. 0 by plus and minus 2, 0 by plus and minus 1. Since the vertices are on the y-axis, we'll put the y in front. Y squared over this 1 squared minus x squared over b squared. We need to determine b. Well, c squared is 1 squared plus b squared. C is 2. 2 squared equals 1 squared plus b squared, which gets you to b is root 3. So y squared over 1 squared minus x squared over root 3 squared equals 1. Or in other words, y squared over 1 minus x squared over 3 equals 1. And that is the equation. Find the equation for the hyperbola with the foci at plus or minus 5 by 0. So these are on the x-axis. So x squared will be the first term. The length of the transverse axis, that's the distance from the center to the vertices, is 6. So horizontal transverse axis, the distance to the vertices is 6/2 or 3. So the vertices are plus or minus 3 by 0. So y squared over 3, x squared over 3 squared minus y squared over b squared equals 1. Now to find b. C squared equals a squared plus b squared. C is 5. 5 squared equals 3 squared plus b squared. After a bit of arithmetic, b is 4. 3, 4, 5 triangle. B squared is 16. So x squared over 3 squared minus y squared over 4 squared equals 1. Or in other words, x squared over 9 minus y squared over 16 equals 1. And those are the equations. Okay.